Good morning. My name is Nayeli from the TN41 group, and today I'm going to talk to you about the extrusion process as a thermodynamic system. Introduction. Thermodynamics is a science applied to solving practical problems. Thermodynamics deals with basic things that are present in our life. It is based on the basic principles of physics, of which it's a part. These are the principles of conservation of energy, or fifth principles of thermodynamics, the principles of conservation of mass, the principles of conservation of a momentum, and the second principles of thermodynamics. Thermodynamic systems. Also called working substance. It is defined and the part of the understudy. A thermodynamic system can be a cell, a person, the stream from the steam engine, the mixture of gasoline and air in a thermal engine, the Earth's atmosphere, etc. The thermodynamic system can be separate from the resource of the universe, called the surroundings of the system, by real or imaginary walls. Thermodynamic system. There are three thermodynamic systems. For example, in solid system, it's one that does not exchange neither matter nor energy with the surroundings. Open system. It's one that exchange energy and matter with the surroundings. Closed system. It's one that exchanges energy, heat and work, but not matter with the surroundings. Its mass remains constant. Now let's go and talk about the extrusion process. thermodynamics and the extruder. Throughout the extrusion process, we can observe some of the types of thermodynamic system, which can be observed throughout this presentation. In this process, for the most part, we have energy transfer from the machine to the thermoplastic or pellet, which will later be transformed into a new raw material. In the textile industry, this process is essential for the production of synthetic fibers so that they can subsequently be used in any textile article. The term extrusion comes from the Latin and means the prefix ex, which means outside, and truder, which means to push. It is a continuous process in which the resin is melted by the action of the temperature and friction. The resin is forced to go through a die that gives it a definite shape and cooled, finally to avoid permanent deformation. By this process could be made tubes, profiles, films, hose, sheet, filaments, and pellets. The main goal: converting a suitable raw material into the specific strange section product, forcing the material through a hole or die under regular condensation. For the process materials, the materials used in the extrusion process are generally thermoplastic. These materials soften when heated and become fluids, which later harden when cooled and turn into solids. Extrusion. Now let's go and talk about the extrusion process. For example, extrusion can be continuous, theoretically producing an indefinitely long pies, or semi-continuous producing many pies. Then, the extrusion process can be done with hot or cold raw material. Also, extrusion is not just for plastic resins. Other commonly extruded materials are metals, polymers, ceramics, cement, modeling clay, and food products. All extrusion products are generally called extrudates. Now let's go into describe the process. The extrude generally consists of one or two screws that rotate inside a hot barrel. The head of an extruder is a screw that is capable of pumping a material at a specific speed under certain operating conditions, while the screws are used for compound and powered raw materials. Then the screw doesn't follow case process requirements such as throughput rate, casting quality, and use of raw materials. The screw, as in the case of twin screw extrusion, force the page of the resin through the die, making the resin take the desired shape The extruded materials cool and solidifies as is putting through the dry or in a weather bath. Finally, a squeegee is used to provide the tension in the extrusion line that is essential to quality of the extrudate. Pelletizers can also create that tension while pulling extruded filaments to cut. For example, the screw has four main functions that are pressurizing, heading, missing, and pumping. And to be more efficient each function, the screw is divided into the zones: feeding zone, compression zone, dosing zone. Now let's go into describe step by step each section. The feed section is the part of the screw or spindle where the unmilled polymer enters the barrel. The rotating spindle moves the material along the barrel to start melting. In the compression section, gas such as air and gas emitted by the resin itself and volatiles such as humidity are removed while the depth of the screw flight decreases and gas and volatiles are pushed back in the direction of the copper. In the dosing section, the pressure is generally which allows the materials to be transported to the modeling area, such as a block or a field drive. We will start with the feeding area. To understand the transport mechanisms of the extrusion spindle, it is important to understand that when the spindle rotates, any materials located between the surface of the spindle and the barrel wall will be transported depending on the direction of rotation. Then comes the compression zone. The resin granules mill with each rotation of the spindle and the compression section, where the space between the screw and the barrel decreases with each rotation. The material means mainly by friction and the transport. It is the compression where the volatiles are pushed back towards at the hopper. Finally, we have the dosing area. In the dosing section, the depth of the flight of the spindle in the shortest, but it remains the same throughout this section in order to homogenize the molten mass in preparing it to be transported to the die where it will form. Another function of the dosing section is to increase the pressure, which depends on the length of the dosing section. Now let's go and talk about filament and yarn extrusion. We will start with the spinning process. Spinning is a manufacturing process to make fiber from a polymer. It is a specialized form extrusion that uses a spinning machine to form multiple continuous filaments. There are many forms of the spinning: wet, dry, jet, mill, reaction, and electrospin. Later comes the fiber yarn. This method is used to make synthetic fibers different industries. There are three main types of fiber spinning: mid, solutions, and reaction. It is types of spinning a liquid polymer extruder through a die with several small holes in a spinning machine to form these filaments. As they progress, the filaments solidify and then combine with other filaments to form tears or a stretch to guide the polymer chains. They offer better mechanical properties. We will start by explaining the cast yarn process. This is the most common for the fiber spinning. In this process, polymer already melted or melting the polymer in the form of granules is used at exit of the extrusion die. The filaments are cooled either in the air or with cooling rollers. The filaments can be joined or braided from there before grafting the dirt in its bobbin. It's usually treated with gray weather or a weighting agent and lubricant to facilitate subsequent use. Spinner plates can have up to 8,000 holes, spaced less than millimeter apart. Some other spinning machines have superfine capillaries of 50 microns in diameter. The most used polymers in melt spinning are polyethylene, polypropylene, and nylon or polyamide. There is a synthetic melt spinning scheme. Then comes the solution spinning process. This method is used when the desired polymer does not form a stable mean. These polymers are dissolved in a solution to make them liquid, instead of melting them. The two main forms of the spinning in solution are dry and wet. In dry solution spinning, the polymer is dissolved in a volatile solvent. Once dissolved, the polymer in solution is extruded throughout a spinning machine surrounded by a drying tower. The solution goes throughout a dry process where the solvent is evaporated. In solution spinning, the polymer is dissolved in a not volatile solvent. The spinner placed in the coagulating bath causes the fiber to precipitate. The liquid in the coagulating bath is selected so that the solvent is soluble in it, but the polymer is not. This allows the polymer to precipitate and form the required solid filaments. The solvent can be recombined at the end of the process. The drag of the coagulating liquid in the filament significantly reduces the production speed, making it a slower process than the mild or dry solution process. Finally, we have the thread by reaction. This process involves the cross-linking of monomers or prepolymers to create a new polymer using a steam chain reaction. This process is similar to the dry solution process, but with additional step. During polymerization, the shortened monomer chains react to form longer, more interconnected chains. This is the cross-linking that allows polymer fiber with good mechanical properties. This is the process by which elastan polyester fibers are made. Reaction yarn is used to cross-link a flexible polymer with a rigid one, obtaining strong, durable, and stretchable fiber. In the following video, we can see an example of the extrusion process of synthetic fibers.
Las fibras de nylon o las fibras de polipropileno son más resistentes que las fibras naturales extraídas del cáñamo de Manila o del sisal. No les afecta el clima y duran mucho más.
Con frecuencia las cuerdas se fabrican a medida de las necesidades de cada cliente. Como este pedido especial de cuerda de polipropileno que está fabricando la fábrica de cuerdas Bebis. Todo empieza con las bolitas de resina. En la máquina mezcladora se combinan con otros ingredientes para crear la fórmula exacta pedida por el cliente.
Comenzamos añadiendo el concentrado de color y algunos productos químicos para conseguir la lubricidad, la estabilización UV y la resistencia a la abrasión deseadas.
Posteriormente las bolitas se transforman en las fibras de la cuerda en una máquina llamada extrusora.
Entran en la máquina a unos 32 grados centígrados de temperatura y recorren toda la máquina. Esto de aquí es una espiral y lo que hace es ir girando constantemente para aumentar la presión y la temperatura.
Cuando las bolitas entran en la máquina, su temperatura aumenta vertiginosamente debido a la acción de una serie de bandas de calor. La espiral aumenta este calor comprimiendo las bolitas cada vez más y más, creando fricción y aumentando la temperatura todavía más. Cuando llegan al final de la máquina, su temperatura alcanza los 254 grados centígrados y las bolitas de resina se han transformado en plástico fundido.
Caen por aquí en este baño de agua. Las ponemos en agua para poder volver a tocarlas. De lo contrario, se pegarían unas con otras. Aquí es donde se separan las fibras. Luego pasan por unos secadores de aire que eliminan el resto de agua. Luego, las fibras pasan por este juego de rodillos. Hacen dos cosas. En primer lugar, sacan las fibras de la máquina. Pero también cumplen la función de un sistema de frenado para el siguiente proceso, en el que girarán 6, 7, 8 o 9 veces más rápido. En este momento, estas fibras que están sometidas a una gran tensión entran en este horno. Aquí están a una temperatura de 175 grados y es en este horno donde estiramos las fibras y donde adquieren su resistencia a la tensión.
El estiramiento de los ramales es la parte más importante del proceso, porque es aquí donde el fabricante crea la resistencia a la tensión que tendrá la futura cuerda. Los ramales se estiran entre 4 y 8 veces. Cuanto más se estiran, más resistentes serán. Eso es debido a que el estiramiento activa las moléculas de las fibras, haciendo que se unan con más fuerza cada vez que pasan por los rodillos. Cuando se consigue la resistencia deseada, los ramales pasan a la siguiente fase del proceso, donde se enrollan en bobinas. Las bobinas son llevadas a una máquina que trenza los ramales de fibra. Y luego pasan a la máquina que hace la cuerda.
Y aquí finaliza el proceso. Aquí es donde se hace la cuerda. Hemos extruido la fibra, la hemos trenzado y ahora la metemos en esta máquina. La fibra llega hasta aquí, donde se forma una cuerda de 3 ramales. Hay 3 ramales diferentes, y esos 3 ramales forman una cuerda de 3 ramales. Cuando llega aquí pasa por una serie de cabestrantes que tiran de la cuerda y la someten a una gran tensión y presión. En este caso es cuerda amarilla de polipropileno.
Así es como se fabrica una cuerda resistente y duradera. Ahora ya podemos atar lo que queramos. Pero ¿y si queremos guardar algo bajo llave?
Thanks for your attention. Bye.